I'm here to present the production readiness review of Team 105 regarding the CubeSat microfluid platform for biological experiments in a space environment, or microbiosat. The concept idea of this project is to create an environment of biological coexistence so that bacteria can grow in a space environment. To verify growth, a spectrophotometer is needed, and this is the group's great challenge, to create one that fits the CubeSat standard. The main objectives of the project are to make the Rio de Janeiro a reference in the aerospace sector, and for this we have the vision that participation in LASC events will bring us greater visibility, create enough Earth oxygen farm from feasibility study of our hypothesis with the chosen bacteria, check the effects of hyper and hypogravity on cells, and develop a low-cost spectrophotometer embedded in one new CubeSat. Development of this project, 3 working groups were needed: mechanics, electronics, and experiments. In the next slides, the main results of each of these working groups will be discussed. The group of experiments needed to verify if the hypothesis of coexistence would be true for cases with different concentrations of the bacteria. Fortunately, everything was confirmed, but in maxima bacteria it was verified that the growth occurs differently when different concentrations of the medium are used. After tests with the photobioreactor, inoculation tests of the bacteria were carried out in an 8-well microdevice. Then, a new 24-well microdevice model was designed. The 3D model of the lead can be seen in Figure 10. The electronics group, in turn, had their first experience with SMD soldering, where everything was somewhat artisanal but little interfered in the operation of the components. The team had access to Pion's educational platform with the Pion kit, and the first tests of LED and phototransistors expansion plates were carried out to identify bacterial growth. Table 1 shows the values in bits recorded by the phototransistor for cases with different mediums light passed through. Figure 14 shows an integration of the spectrophotometer plates with the Pion kit. The service module used by MinervaSat's team is the same as the one used by Minerva rockets. Figures 15 and 16 shows the 3D model of the CDHS and EPS. Now, with the mechanics subsystem, the main products can be shown first: a 1U CubeSat structure and a 2U structure. The other great product developed by mechanics was the final module that will insulate biological experiments thermally and protect from light interference. Figure 20 shows how the final product will look, where the biomodule is located at the top like a small box. As we needed to hit a given payload load weight in order to prevent the need of using that weight in Minerva rockets launchers, SensoSat, a remote sensing CubeSat, was chosen to be part of this mission. At first, it will only be used to generate images and perform small tests associated with the ADCS system, or Attitude Determination and Control System, and to take images stabilized through a reaction wheel-sized part. We have some of the main reference of the project here, and this was the presentation of microbiosat CubeSat, and I'd like to thank you very much for your attention. Avante!